Hello and welcome to Data Analysis and Visualization. I'm Jivita Christie, and in this video, I'm going to talk to you about how you can calculate probability, the different rules to calculate probability, and at the same time, we are also going to learn about permutations. So let's begin. So the first rule that we're going to talk about is known as the addition rule. We are going to take an example to understand this rule, and the example is about rolling a dice. So if you're rolling a dice, then what is the probability of getting a 1 or a 6? So a dice has 6 sides, and out of the 6 sides, you want to know the probability of getting either a 1 or a 6 value. So here we are going to be applying the addition rule, and here the probability of getting any digit in one roll is obviously 1 by 6 because there are 6 sides to a dice, and that's why if you want to know probability of getting a 2 or a 3 or a 4, it's always going to be 1 by 6. So using that, probability of getting 1 is 1 by 6. Probability of getting 6 is also 1 by 6. Now our question was, what is the probability of getting 1 or 6? And this probability is going to be 1 by 6 plus 1 by 6, which gives you 2 by 6, and that can be 1 by 3. So this is the addition rule. Whenever there is a question that says either this occurs, either this event occurs or that event occurs, and you have to find the probability of either of those events occurring, then you always use the addition rule as it is used here. So it is written as P of A or B is equal to P of A plus P of B. And it is also written sometimes in terms of set operation like union, and it is written as P of A union B is equal to P of A plus P of B. And as this rule can work for not just 2 events, it can work for 2 or more events. So if you wanted to expand this rule to accommodate 3 events, A, B, and C, then you would be writing it as P of A union B union C is equal to P of A plus P of B plus P of C. So this is how the addition rule works, and this is the formula for it. Now let's take another example. So we have a bag of 30 marbles. Out of that, there are 12 green marbles, 8 blue marbles, and 10 black marbles. So this is the bag of marbles: 12 green, 9 blue, and 10 black, and totally 30 marbles. Now what we want to find out is what are the chances of pulling a green or a blue marble out at random. So remember that we have 12 green marbles, 8 blue marbles, and 10 black marbles. Out of this, I want to find out what is the probability or chance means probability, of getting a green or a blue marble if I were to put my hand into this particular bag of marbles. So it can be calculated like this. We want to find the probability of getting a green or a blue marble. So it is P of G union B, which is going to be equal to 12 into 12 plus 8 plus 10, because that is the total probability, 12 plus 8 plus 10, plus you're going to add to it 8. Sorry, this is 12 divided by 12 plus 8 plus 10, and then you're going to add to it 8 divided by 12 plus 8 plus 10. And the reason why we are doing this is because we are applying the addition rule formula, which would say that 30, which is the total number of marbles, is equal to probability of getting green marbles, blue marbles, and black marbles. And so you're adding all those. And here you want to find the probability of getting either a green marble or a blue marble. So that is why we are using this formula. And using this, probability of getting a green marble or a blue marble would be simply probability of getting a green marble plus probability of getting a blue marble. So what is the probability of getting green marbles? There are 12 green marbles and there are totally 30 marbles. So the probability is 12 by 30. And what's the probability of getting a blue marble? This is 8 by 30 because there are 8 blue marbles and totally 30 marbles. So 12 by 30 plus 8 by 30, and that is equal to 20 by 30, which you can simplify to 2 by 3. So that's how we calculated the probability of getting either a green marble or a blue marble out of a bag of 30 marbles. So that's how addition rule can be applied in practice. Now there's something called mutually exclusive events. So this is when both outcomes cannot happen together. And it can be illustrated by a Venn diagram in this manner. So mutually exclusive events are all about outcomes that cannot happen together, things that cannot happen together, two events that cannot occur at the same time. And we are going to see a little bit about these events. So mutually exclusive events are like this. This is an example. So we say that suppose we have a class of 13 students and we have 7 females and 6 males, and we are trying to form a small committee out of these 13 students, and the committee has to be of 3 students. And we want to know what is the probability that the committee is going to have 2 or more female students. This is a mutually exclusive event. Now let's talk about events that are not mutually exclusive events. So you have a deck of cards, and what is the probability that you pick a card and that card is going to be either a king or a hearts? Now this is a non-mutually exclusive event because there is a possibility that the card you pick is the king of hearts. So to calculate this, we are going to do it in this manner. So first of all, we are going to find the probability of finding a king, and we are denoting that event as event A. So the probability is 4 by 52 because a deck of cards contains 52 cards, and out of those there are 4 kings. So 4 by 52. Now what's the probability of getting hearts? So we are denoting that as event B, and that is 13 by 52 because once again there are 52 cards and the total number of cards in the heart suit are 13, so 13 by 52. Now what is the probability of B of getting a king, and that king is the king of hearts? That probability is definitely 1 by 52 because there is only one such card in the deck. And so that is P of A intersection B. Now, what is the probability of getting either A or B? So that means we are trying to find P of A union B. Now that probability is 4 by 52 plus 13 by 52. So we add those two, and from there we subtract the probability of both events happening together, because the question is not that the card is a king of hearts, but the question is that what's the probability that it is either a king or a hearts card, but not both. And that's why we are subtracting this from here. And so what we get is 16 by 52. So the probability of the card being either a king or a heart is 4 by 13, simplified version, and that gives us 0.31. So this is how you can calculate when you're working with non-mutually exclusive events. Now let's see some other probability problems. So what is the probability of pulling three aces in a row? What is the probability of pulling three aces in a row? So you have 52 cards. You are picking one card at a time, and you're doing this three times. So if you're doing it three times, then what is the probability that all three times you are going to pick an ace? So remember that there are four aces in the deck of 52 cards. The probability of getting one ace is 4 by 52 definitely. But what about the probability of getting a second ace after you've picked the first one? Would it still be 4 by 52? No, it wouldn't. And we are going to see here how, because now after picking one card from the deck, you are left with only three aces in the deck, if suppose that was an ace. And also the deck now contains only 51 cards. So you have to modify your calculation and do it in this manner. You would be writing P of three aces. So earlier it was P of picking just one ace, which is probability of picking one ace, which is 4 by 52. But now picking three aces in succession would be 4 by 52. Multiply that by 3 by 51, and then multiply that by 2 by 50. So this 4 by 52 is picking the first ace, 3 by 51 is picking the second ace, and 2 by 50 is picking the third ace. And that gives you 1 by 5,525, which results in this value 0.000181. You can verify that for yourself. So this is an example of a sampling without replacement, which means you did go into the deck of cards, you picked a card, but afterwards, before making another attempt to pick a card, you did not put your original card back. So this is an example of a sampling without replacement. That brings us to our next rule, which is the product rule. So let's explore the tossing of two coins. You have two coins, the sample space for tossing these two coins, and I have explained sample spaces in my previous video. So in case you need to revise that, you can watch that video. So capital S is what denotes a sample space, which are the total outcomes, list of outcomes, and here the outcomes are heads or tails. If you toss a coin, you're going to either get heads or tails. So number of outcomes for coin A, because we are talking about tossing of two coins. So if you have two coins, the number of outcomes of tossing one coin is going to be 2, and number of outcomes of tossing another coin B, which is it's also going to be 2. So therefore the total outcomes will increase. Now the total outcomes are 2 into 2, which is 4, and not just 2 as we saw before. So consider that you have a combination lock with a 2-digit code, okay? And what are the odds of guessing the code in your first guess? Okay, so this is the question, that you have a lock, and that lock contains, it's a digit lock, so it contains 2 digits, and if you get the correct combination of those 2 digits, then the lock opens. So if you were to guess the correct code, what would be the probability of getting the first guess correct? What is the probability of getting it correct in the first guess? So first of all, in this, the probability of E, which means the event that I guessed the lock code correctly in my first guess, is equal to number of successions divided by number of successes divided by number of outcomes. So we are going to define two sample spaces. The first sample space is the first digit of my lock, which can be anything from 0 to 9. So that is my first sample space. The second sample space is the second digit of my lock, and that also can be anything from 0 to 9. So these are the two sample spaces. And that's why for each digit, the number of possible values are 10, and the number of possible values is 10, and that is why this is how we can calculate the probability, which is P of E is equal to 1 divided by 10 cross 10, because there are 10 possibilities each, and that's why it's going to be 1 divided by 100, which gives you 0.01. So if you were working with a say 4-digit lock instead of a 2-digit lock, you'll just increase the number of zeros and it will become 0.0001. So that's the product rule for you. And now we are going to talk about permutations, because we just explored an ordered set of numbers in order to get the probability of guessing the combination lock. Now, any ordered combination of elements is known as a permutation. And we're going to see how that affects the calculation of probability. So first of all, the order matters, because the lock, suppose you had a lock with 4 digits and say that the code to unlock was 1, 2, 3, 4. But instead of that, you typed in 4, 3, 2, 1, or you used 2, 3, 4, 1. Would the lock open? No, it wouldn't. And that's why the order is important in some of the cases. And that's why when we calculate probability, we have to consider the order of these items also. Now, there are two kinds of permutations. First, we have permutations with repetition, and we also have permutations without repetition. So first, we are going to go through permutations with repetitions. So if you had to find out the lock combination, then you know that the digits can be repeated. My lock combination could be 1, 1, 1, 1, which means all are ones, and there is repetition. So calculating number of possibilities is quite easy. If you have n choices, a number of outcomes for n choices, then it's simply n1 into n2 into n3 like we did previously. We just multiplied 10 and 10 because each digit has 10 choices. So it's very easy when you're working with permutations with repetitions. Now, what about permutations without repetitions? So consider this example where you have 16 numbered pool balls. So pool is a game that you can play where there are balls and each ball has a number written. So let's consider that there are 16 such balls, and on each ball there is a number written 1, 2, 3, 4 unique numbers from 1 to 16. Okay. So permutation without repetition is where once an outcome occurs, you cannot replace it. You're not going to replace it. That is permutation without repetition. So suppose you are randomly choosing a ball out of these 16 balls. Okay. Then after choosing that ball, say that ball was 5, then you would be removing 5 from those 16 possibilities, and that's why now you are left with only 15 possibilities. To calculate the number of possible combinations in this case, we would be doing this. We are doing 16 into 15 into 14 into 13 and so on up to 1, because every time one ball is reduced. And that's why the total possibilities are 16 factorial. This is what a factorial looks like. You're just reducing one number at a time and multiplying them. So this is what permutation without repetition looks like. Now, when you're randomly choosing the first ball, now let's say that you wanted to choose 3 random pool balls out of the set of 16. Then how many different combinations of balls can you get? So there are 16 balls, you're choosing 3. So what are the different combinations of 3 that you can get? And remember that order does matter because it's a permutation. And it's also a permutation without repetition, which means once you've picked a ball, you're not going to put it back in the set of balls. So in this case, it will be 16 factorial divided by 13 factorial. It will be this, which is 3860 permutations. Sorry, it's going to be 13 factorial divided by 16 factorial. And how do you calculate it? This is the formula, which is n factorial upon n minus r factorial. So the question now that we are going to work with is this, that you want to choose out of a set of 16 balls, you want to choose 3 balls. So if you were doing that, if you were to do that, then what are the total possible combinations that you can have of 3 balls from a set of 16? And that would be 16 factorial divided by 13 factorial in this manner, which gives you 3360 permutations, as you can see. And the formula for that is this, which is n factorial divided by n minus r factorial in this manner. So here n tells you how many total balls you have, which are 16, and r defines how many you are trying to pick at once, and those are 3. So that's why it's going to be 16 factorial divided by 16 minus 3 factorial, which gives you 16 factorial divided by 13 factorial. So this is the formula, and like I said, this is just a recap that here n is number of possible things to choose from, and r is the number of repetitions, how many times you are choosing it. And this is the formula that you would want to remember, because it's going to help us later on as we study this subject of data analysis and visualization. And with this, I'm going to end this video. But I'll be back with the next video, where once again we are going to continue to study probability, and we're going to study a very important form of conditional probability, which is known as the Bayes theorem. So I'll see you in that next video, and thank you for watching.